actually, kind of luckily, haven't thought of it at all. Okay. Write a method named insert interval that inserts a new interval into a list of intervals, merging as needed. Your method accepts two parameters, a list of two-element lists of integers representing the set of non-overlapping intervals sorted by starting number, and a single two-element list representing a new interval to insert. For example, if the list of existing intervals is 1, 2, 3, 5, 6, 7, 8, 10, 12, 16, and the new interval you insert is 4, 8, you should return that. Okay, you may assume the input data is valid. Okay, cool. So right now, the reason I'm doing this, one is maybe just for y'all to see, you know, what my first attempt would look like, but also I kind of want to go over the process that we do. So like the general stuff. I'm not like, this isn't about interval problems or anything. This is just like general stuff I do for all problems, and I kind of want to highlight that. So the first step,
that sounds great,
that I always do is I try to understand the problem, right? So this can look like a bunch of things. One thing you can do in this step is you can draw pictures. Another thing you can do in this step is walk through examples. You know, either given or you come up with. So walk through examples either that you're given or that you come up with, right? So so I'm just going to do step 1 right now. Okay. So for insert interval, these are the intervals. And it looks, I mean, yeah, I believe it says that they are non-overlapping intervals. Yeah, a set of non-overlapping intervals. So actually for this example, I'm actually going to just, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. So I've got one from 1 to 2. I'm going to draw this interval like that. And then I've got one from 3 to 4, 5. That's what that interval looks like. And then I've got an interval 6 to 7. Right? I'm just going to say like 1, and this is 16. Okay. And then 8 to 10. So this was 7. So 8, 9, 10. Got intervals like this. 12. So 11 gets skipped. 12 to 16. 12, 13, 14, 15, 16. The last one. Okay. So in the example that I was given, this is what those intervals look like. Right? This is how I'm visualizing them. And then I'm given 4, 8. So typically this is like I bust out a different color, but I don't have like this is new software to me. I don't have like a little palette that I don't really know how to use it. So I'm just going to use the same color. So I'll just say, this is my intervals that I'm given. And then, you know, I'm given one called, I'll just call it to insert.
Is there a color selector in the top right?
Yeah, but I don't know how I'd get, maybe.
Or isn't like the wheel on the outside? Can't you like click that?
Yeah, but then I don't know how I'd get back to this one.
Oh, I see.
And then I'm it just be tons of colors, and I don't know.
Yeah.
But to insert goes from 4 to 8. So 1, 2, 3, 4, to 8. 1, 2, 4, 5, 6, 7, 8. All right, okay, yeah, it looks like I changed the color. Darker purple now. Okay. So, okay, I see. Yeah. So this should return. So basically, these, in this example, these three were kind of merged, right? So that is, okay. That's what the problem is. I understand, I understand it. Yeah. So I guess it's at this point, and I probably they wouldn't say you may assume input is valid on an interview, and so that's where I would ask questions like, are the intervals the intervals that I'm given, are they overlapping? And they'd say no, they're all non-overlapping. And I'd go, okay, cool. Are they always given to me in sorted order? And they'd say, yeah, we can assume they're given to you in sorted order, right? And I'd go, okay, cool. So that's sick. Okay, so at this point, I feel like I've kind of declared a victory on step 1, right? I've done understanding the problem. And like, I feel like I understand it, and the interviewer is probably also pretty sure that I understand the problem. So that's what step 1 looks like, right? Kind of emphasizing that a lot because, sometimes people do tech interviews and within the first 30 seconds, they start writing code. It's crazy, right? Like, we need to understand the problem. So I've done that, and yeah, we're a few minutes in. Cool. Okay. So step 2 is to come up with algorithm, right? And so here we can just be like, I'm just gonna say playing around with stuff. We'll see what that looks like. Maybe writing bullet points. I'm just gonna say this is like high level. So I'm not like writing pseudocode here. That's actually step 3. I'm just like playing around with stuff and trying to come up with an algorithm high level, right? So I'm gonna go ahead and do this step right now. I'm also gonna scroll down a smidge. Okay. At this point, we've got all that. Okay, cool. So basically, I'm looking at this, and I feel like I kind of have. Let me think. There's a number of cases here. Like, there's the case where things get. Let me think for a sec. So, okay, wait. So let's say we've got something like this. So this is my intervals. And I'm just gonna say i's intervals, and then to insert. So we have something like this, right? That's going to result in, this, right? Because none of them were overlapping, so we just insert this, bam. So we've also got one where, let's say, just the left side is overlapping. So let's say we have something like this, right? That's going to result in that. So it just overlapped on the left. We've got a similar one where, you know, it just overlaps on the right, right? And then you've got kind of the one like this one where it overlaps on both, and that could be actually there's another case I just thought of, and I don't know if I need like special cases for all these. I'm just kind of like thinking about different things that could happen. You know, what if I'm given, you know, I'll just do that, right? And then also this, right? Like, there's something like this where I'm given a really big interval, or like, you know, the intervals that I'm given are totally encompassed in this, so there's just no change, right? Okay, so these are kind of some different cases that I'm thinking of, and I'm going to want to keep all of those in mind. Maybe when I'm like, if I've come up with an algorithm, I'm going to want to make sure kind of all of these cases work, right? Okay, so basically what I'm thinking, so I'm kind of thinking of like this iterating like O of n solution, where n is the number of intervals in our thing, where, you know, first I look at the start, right? So I'd look at 4, and I'd say, okay, find me an interval that 4 falls into, right? Because these are non-overlapping, the 4 can only go into 1 or 0 of those intervals, right? So I'm just gonna call this the left interval, right? This is the interval that I was given. So for this one, right, it would return this second. It'd return this 3, 5. Does that make sense? So that's the left interval.
Yeah.
So I'm going to say get I'll just say like get interval containing, oh whoops, that's bad handwriting, containing, and I'll pass in, you know, the start, or my left one, and I'll say like, you know, that's left interval. So if I get, actually I'm kind of getting ahead of myself because that's looking pretty pseudocodey, but basically if I get this left one and I get the right one, right, and we're doing, yeah, so this, for this problem, it would return this guy and then this guy, right? And basically I'd say I'm going to, for this problem, I'm only thinking about this problem right now. I would say, okay, let me remove these intervals and replace them with, you know, the left intervals start and the right intervals end, right?
Yeah.
So does that, so I mean that works for that one. Let me consider these cases real quick. So if I get the left interval here, there won't be one. There's no interval, right? And if I get the right interval here, there won't be one. So if there was no left interval and there was no right interval, then that means that this is just going to be inserted as its own interval, right? And so at that point, I can just kind of find the spot in the list where it's supposed to be inserted, put it there, and I'm done, right? So I like that. Then there's this case where there is a left interval, but there's not a right interval. In that case, I just replace that left interval with the, I take this and this and make one interval and replace that. Bam, right?
Right.
Same thing with this one, except, there was no left, but there was a right. Bam, so I do that. And then there's this where I guess I'd just say the left interval and the right interval were the same one. And if the left interval and the right interval are the same array, then we're done. We do nothing because it would have been completely engulfed by that longer interval.
Engulfed.
Yeah. Does that make sense?
Yeah. It's making
Okay.
sense so far.
Okay. So in this case, I'm going to get the left interval. So, okay. At that point, before I go to step 3, actually, which is to write pseudocode, I have to say the runtime, and space complexity. Okay. So the time and space complexity here. I think this could be done in log n time. So, okay. What I just illustrated, right, was doing it in O of n time. So getting the left interval would be O of n time because I'm just going and looking for it, right?
Yeah.
Getting the right interval would be O of n time because I'd just be looking at it, right?
Right.
And then, let me think. Yeah, and then, replacing them would be, certainly not as bad as, O of n in the worst case, but actually replacing them, it depends on the data structure we're given. But that might be O of n replacing. So I guess the algorithm that I just described was O of n. However, I'm thinking it might be possible to find the the left interval and the right interval in log n time, but that kind of depends on like the data structure that we're given out the gate. So if I'm given an array list out the gate, basically if I have O of 1 access to all of these elements, then I could do a binary search is kind of what I'm getting at. I could do a binary search, I think, to find the left interval in log n time, and then a binary search. So, what this would look like would be, 4. Okay, I want to find an interval that would contain 4. So I'd start by, I could look here. Or I'd start in the middle.
Yeah.
I'd start in the middle. So I've got 4, and that's 6. And I'd say, okay, well, 4 is less than 6, so I'm going to the left. And then this would say, okay, 4 and 3, 4 is greater than it. And since 4 is greater than this, I could check if it's contained in this interval. And since it is contained in that interval, boom, I found it. And it only took 2 operations. So that's a log n way to do it. I kind of, yeah. I'm going to, for sake of simplicity, maybe just implement get interval containing in n time. because I guess if I were given an array here, let's say I had a million elements that were all, intervals of size 1, basically. So I have tons of little intervals, right? Like this. Let's say this was a million little intervals, right? And then I were to replace that with one big interval. Our runtime for this problem would still be O of n. Because I'd need to remove all of these from the array list that were given. And then, put this there. So doing that in log n doesn't actually increase the big O time complexity of our solution. So for sake of simplicity, I'm just going to, when I have to implement that, I'm just going to do it in linear time. But if I were actually implementing it, I'd do a binary search. Okay, cool. All right, so that is the vibe. So basically, the time complexity of this is O of n, and the space complexity is constant, because this algorithm does not require me to allocate any new space. You'll go over time and space complexity more in 143, by the way. So, and they also go over it way more nowadays than they did back when we took the course even. It's interesting. Okay, so now that I've talked about the runtime and space complexity, because often you come up with a solution and then you come up with the time and space complexity and you go, could I do better? Which is kind of what I just did, right? I was like, actually, I could maybe do this in log n time. And I talk about it a bit, but I ended up being lazy. So, okay. So now we write pseudocode, right? And sorry, is this a lot of repeating? Y'all have been doing this problem for 2 hours now?
No, what I was gonna say is so interesting is how hesitant you were to get to the next, just how much you wanted to do before you wrote pseudocode just made me laugh, I think.
Yeah.
Which is you're really embodying the principle of don't write code first.
Yeah, no, it's I guess it's laughable. Damn, how long are we're still not writing code, right? Because we've done all this and now we're writing pseudocode. Okay, so
it's great.
Left interval equals get interval containing. I mean, some bullet points I would have here is make up subroutines. Right? I'm making up subroutines. Get interval containing. That's just a subroutine, right? So then right interval is going to be get interval containing sorry, wait, my phone's ringing. No, it ain't. Not no mo. Okay, so get interval containing of, I'll just say end. These are the start and end of the interval that we're inserting, right? Okay, so now, and these are I guess I'll just say these will be null if there is no interval, right? So, but that's lower level than we need to get. Okay, so, what was all the shit that I just said? Basically, I said, I guess if there is a left interval, if there is a left interval, right? Because this, we could have not found one. This shouldn't be indented. Okay, if there is a left interval, then I'm gonna want to do some stuff. Actually, I'm gonna come up with that last case first. So I'm gonna say if there is not a left or right interval. So if there's not a left or right interval, what do I want to do? I want to find where new should be inserted and put it there. Right? We're looking at the case like this. No, sorry. We're looking at this case, right? There was no left interval. There was no right interval. Let's just put it in where it belongs. Boom. That case is covered in our pseudocode. Okay. Now I'm going to do the case where there's both a left and a right interval, which is like this one and this one, right? So I'll say, else if both left and right interval exist, right? If both the left and the right interval exist, then I'm going to do different things in this case. So basically, special case, look out, I'm going to say if left interval is equal to right interval, then, I return, right? That was this case. Oh, there's a left and a right interval, but they're the same thing. I'm engulfed. I do nothing. We're done with the method, right? Okay. Otherwise, they're different. So what we need to do is we need to create a new interval from I guess left interval dot start. I'll just say left interval dot start, right interval dot end, right? Feel good. Create the new interval. Then delete all intervals between left interval and right interval.
Really fast, Todd, are you assuming that you're modifying the given list?
I was assuming that.
You're not.
Okay.
Wait, more accurately, it doesn't tell you whether you are, right?
Yeah, it's pretty ambiguous in the question, but
Yeah.
but the it's going to grade it as if you have to.
Okay.
It does say return in the example, but yeah.
That's a good point.
Okay. Oh, so I need to okay. Shit. Most of my stuff still most of my stuff still applies. Yeah, I guess here though, yeah, I don't need to delete the intervals between this. I just need to I guess okay. There's a couple things I could do here. One is while I was I could be building up my result as I go through. So if I'm doing get left or like get interval here, I can be like adding this stuff like boom, boom, boom. But I think what I want to do here actually is maybe I can if I can just keep track of the interval that I'm adding. So if I just keep track of this, right? Then at the end, I can just like say, okay, now that I have the interval that I'm adding, I can just go through this and say, okay, I'm adding this. Oh, but since this overlaps with that interval, I don't add it. Since this overlaps with that interval, I don't add it. Since this overlaps with that interval, I don't add it. And then once I reach one that doesn't overlap, I add that interval and add the rest. That's what I'm going to do.
To your like result copy.
Yeah, to my result. Yeah. So basically, right now, I'm just finding my like the new interval. And so this is the algorithm to find the new interval. And then at the end, I'm going to say, okay, I'm going to take that new interval and just go through this, what I'm given, and just like build it up. I would put in 1, 2 because it doesn't overlap with my new interval. I would not put in this because it doesn't overlap, because it does overlap. I would not put in this because it does overlap. I would not put in this because it does overlap. And now that I see one that doesn't overlap, I put in my new one, and then I put in the rest. That should work. Whoops. Okay. Damn, I'm running out of space. Delete all intervals between that. Okay. So this actually is not delete all intervals. So yeah, I'll just say, you know, here I'll actually just say new interval equals this, right? And up here I would say, so let me just run through this logic again with that new revelation. If there is not a left or a right interval, I should probably return, I mean, here I'll just return null, and then later I'll say, oh, if, or I won't return null, but, oh wait, sorry. Oh, this is where I'm inserting one. Okay, yeah. Oh, wait, hold up. Yeah, my logic actually needs to be not just, is this overlapping or not? But it needs to be, is it to the left? So basically it would say, while these are to the, I mean, that'll be a separate problem. I'll solve that separately. But it's basically going to be, while these are to the left, insert them into my result. And then while they're overlapping, just iterate. And then since these are to the right, yeah, okay, cool. So then in this case, if there is not a left or a right interval, that means that I'll go through while it's to the left and insert them. And then once I see one that's to the right, that's when I insert it, right? But it needs to not just be is overlapping or not. It needs to be is to the left or is to the right. Okay, cool. So if both left and right intervals exist, then basically this would be the null case. So I'll just say or actually, I'm not going to call this to insert. I'm going to call it new interval. New interval equals null. And then later I'll just say if new interval is null, it means we're doing nothing. Cool. Okay. Otherwise, both left and right do exist, and they weren't completely engulfed in one of them. So we need to, do this, where we say new interval equals this. I'm going to make this bigger and erase this to gain some space. Okay, vibe check. Y'all been doing this problem for a long time. I don't know how much feel like you're gaining from me doing this. I'm happy to keep going, but I also want to make sure time efficiency is a thing.
Yeah, I think it's been really valuable to see your process so far. I guess how do you
right here, I would basically say, okay, I've checked this case, I've checked this case, and I've checked this case. Now I just need to cover these two, which I'm happy to do. And then from there, I feel like I have my algorithm and I go write code. I think there could be value
you're
in
almost
seeing.
at the point where you feel like you have your algorithm.
Yeah. Or like I have my pseudocode. Yeah.
Right.
Like this stuff, I'm not going to actually implement the get interval containing or something, right? I mean, I'll implement it at the implementation stage, but for now, I'm just like, I don't
Not
know.
yet. Right.
Maybe let me keep running until I get done with the pseudocode.
Yeah.
Till I get to the point where I'm like, all right, I feel like I'm done.
Okay.
So, so it's not the case that neither exists, and it's not the case that, so I'll say else if only the left exists, then I mean, I say, new interval is equal to left interval start, and I'm going to rename it to given, the given interval that I need to insert. So given dot end, right? And then here I could just say else, and it means only the right interval exists. And in that case, new interval is equal to given dot start, and then right interval dot end. Okay. So this is the algorithm to get the new interval, right? This is my, I'll say, get new interval. That's what this is, okay? Bam. That gets the new interval. I then need to create the new list with that new interval. And basically, I think what that algorithm looks like, so I'm just actually going to go over this real quick. Actually, I'm going to call it build result with new interval. Oh man, my handwriting is bad. With new interval, right? So to build the result with my new interval, what I'm going to do is I'm going to say, for each element in my given, or actually I'll say, I'm going to be moving left to right. All right. So I'm actually going to, I'm going to do this with like a while loop. Yeah. So basically I'm going to say cur equals 0. And then I'll say, while element at cur is completely to the left. That means like not overlapping at all. While the element at cur is completely to the left of my new interval, left of new interval, what am I going to do? I'm going to add that element to my result and do cur plus plus. Okay, right? So that's that. Basically, I've got my new interval. While everything's to the left, I add it, right? I also am going to need a special case for a new interval being null. I'm just going to write that right now. If I'll say to insert, actually I'd rather that be called new interval. If new interval is null, I'll just say just copy. I'm just going to copy the result and return it. Okay, cool. Okay, so while the element at cur is completely to the left, we add those. Boom. Okay. And then I'm going to say while element at cur is overlapping, I just do cur plus plus, right? So I'm not adding anything to my result. I'm like, oh, that overlaps in some way, that overlaps in some way, that overlaps in some way. Okay, so at that point, I have now reached the point where I'm looking at an element, and it is to the right of my new interval, or there is no element, right? So actually I need to check here. For all of these, I'm also going to need to check that I haven't run off the end. I need to check for index out of bounds, right? So at this point, I insert new interval, right? So I've inserted a new interval, and then basically I do this again, except with the right one. So, I mean, I'll just say add the rest. Add the rest of the array. So that's that. That's the build result with the new interval. And this is my pseudocode step that I'm now done with. Boom. And from here, writing the code would actually be pretty easy. The only thing I'd really need to figure out is this, like, whatever it was here, the get interval containing, but that's like easy enough. So yeah. And y'all been doing this problem for like hours now. Maybe even I could just like do this and then you could like watch a clip later, but it's kind of cool to see the payoff of like how easy it is to write code when you've written the pseudocode already. So I think either way, I'm going to do this. I might take a little break, but I'm going to do this, and then I can just send you the clip if you are not It's been a really long time.
I've got something that's kind of, I mean, just because like you're mentioning that our heads have been in this problem for so long. I've got a few
Yeah.
things that are sparking for me. But before that, like, what are your thoughts here, Kurt, just in general, and also maybe to do with like, it seems to me like Todd's identified a lot of the things up front. Does it feel that way to you as well, or?
Yeah, yeah. I think definitely that, and as I had, you know, alluded to before, like writing out the edge cases was definitely uh that definitely helps a ton in like, making the problem more manageable. Yeah, I am. And like even as you were going, I was kind of thinking of like other ways to do it too. I'm like, there are kind of different ways of kind of going about this
So yeah, with
problem.
the advantage of having having worked the hard and slow way on this for a long
Right.
time,
Yeah, yeah.
at least myself personally not taking nearly as um, structured of an approach. Now I'm kind of wondering, like, uh, is there a simpler way too? Is there
To
a way to
solve the problem.
refactor these edge cases to where we're taking less pseudocode and eventually have to write less code too?
Oh, like
Because
just
when I
same
see
number
this,
of
I
lines.
see, I'm pretty sure it will work. I mean, I saw Kurt do it too. And it's like, but it's also like, if it was me in an interview with maybe like 20 minutes left to write it up, I'd kind of be feeling like, fuck, like this, it's too much. I don't know if I
Yeah.
can get through this whole thing yet, you know?
Yeah. Yeah. Yeah.
What are your thoughts with respect to that? Like,
It
on the
is.
one hand, I would be proud to have demonstrated the full knowledge of the problem that you've
Yeah.
demonstrated.
But at the end of the day, you need to get code down. You know what I mean? You need to get code down. So there is this vibe sometimes of being like, okay, there's 25, maybe I would have been like, there's 30 minutes left and I'm about to talk about pseudocode for this, right?
Yeah.
I don't know what the time has been. But at that point, and I almost did this, but at that point I was like, is it worth writing pseudocode for this, or can I kind of just explain it and get code down for this,
Yeah.
right? And that is definitely a thing I would have done. Given writing this pseudocode really only took a few minutes, but it is a thing like you can check in and be like, by the way, this is where I'm at. Clearly I have it was probably pretty clear to you that I had a pretty damn good understanding of the problem by the time I finished this, right?
Yeah.
And so at that point, I talk about the building result with the new intervals, but I mean, basically, yeah, at that point, you can always check in and be like, should I keep going with this pseudo, there's always keeping your eye on the clock is kind of important, basically. And
For sure.
I think with this one, I probably, wouldn't have ended up writing this subroutine there. But because it's kind of like, it's crucial logic and it's not trivial, I guess. So I was like, I do want to write it. But I think it's like, if you were pressed for time, you could just talk about, hey, this is what I need to do. This is how I'm going to do it. I really want to get code down, though. The interviewer might go, cool, that sounds good. Get some code down, right? Yeah.
Also to add, you didn't even really think to write pseudocode for instance, like get interval containing. Certain things are like, they're just simple enough to where you're like, I don't need to write pseudocode for that. You're probably not even going to need to write regular code for that. Like if you get to the point where you've implemented both of these things, the interviewer a lot of the times is going to say like, you don't need to implement that, the method that's like really simple, if it's just like a simple iteration and checking thing. But it depends on the interviewer. But
yeah, this one here, get interval containing,
yeah,
often I think I wouldn't be asked to even implement it. It's just so trivially easy that it's like, let's just not even do it.
Huh. Okay.
Yeah. And this one is like almost there, but actually not quite. There's like some logic there that's pretty,
yeah, that one I think is involved enough to where you probably want that.
Okay.
Yeah.
Get interval containing is it's a basic loop with, you're just checking if it's within a single interval within the loop. That's all it is.
This is, I mean, not in the right order. Like, I really sensed one thing I really took away, Todd, was like, you were like, you'd start to go a little bit deeper, then you're like, no, wait. We're gonna stay at the high level until we're done with the high level, and then keep moving. That's something I did not implement. But a lot of what you described these are the kinds of problems that I ran into while trying to solve this. In kind of the worst way of like, oh, now I won't pass that test, and I have to start from the beginning and figure out where that's supposed to go, kind of thing.
Yeah, I kind of think like if I really wanted to learn about like human history, I might start like really high level, like beginning to now, and then like, okay, wait, now I'm going to learn a bunch of stuff, about these particular things, and then like kind of keep breaking it down. So it's like you do a pass at a really high level, and then you do like, then you can kind of dig deeper into these sub things, but it's with this overall understanding, right? And I think like solving these problems, maybe that's a bad analogy, but it's really similar where it's like, you don't want to I don't want to be thinking about this get interval containing. I want all my brain cycles to be able to be allocated on the big picture. You know what I mean? Because the big picture is hard, and I need all of my brain cycles for that. And so you just don't want to like spend your brain cycles on that. Like you can just say I'm going to allocate the brain cycles for that later. And often you never will, because the interviewer will say it's trivial enough, right? But yeah, so it's kind of really getting it high level. And even here, I like started jumping into writing pseudocode, and then I was like, actually, that's lower level than I want to get right now. Yeah. I'm just going to like talk about these cases. Okay, cool. Now that I was able to allocate all my cycles to this, I've like learned this thing, and it'll be easier to do this, without having to like encounter these cases for the first time. I've already thought about those. I've already allocated the brain cycles, and I get it, And that's kind of why we have this. It's like, first you understand the problem. That is like, it's good to understand the problem, but also like doing this rigorously makes this happen easier. Like if I didn't do this and draw out pictures, I might not have thought to draw out pictures for each of these cases, A lot of that is just like a lot of this happened because I spent a bunch of time in this. Make sense?
Yeah. See, now I'm tempted to try and solve the problem with a few, ideas that were kind of sparked for me here.
Yeah, and then you come up with
going from the top level first and just trying to draw it out on paper to try to use the same approach that you did, just so that I don't end up spinning off in the small details.
Mm-hmm. And that, I would say, is like, it is going to be super helpful with the homeworks in 143. This is something that I think is worth practicing.
Yeah.
And like, I think the earlier you practice this, the more hours you will save on the 140. Like, it will be, you'll get a huge payoff. You'll get a huge payoff.
Oh, shit. Word.
Yeah. Yeah, I mean, that's ultimately why I wanted to do this. It's just like, and it's funny, I feel like this sort of stuff, I talk about, it'll help you with the homework. It'll help you when you're doing all these recursive backtracking problems and all this. These are the things to get good at an interview. One thing I've learned in the past 2 months of working with Vanessa is that it turns out the stuff that you need to do to get good at an interview is actually exactly the same as the stuff that you need to do to get good at solving complex problems. Right? Like, if you're solving a complex problem, this is how you should do it. And it, you know, literally there's a rubber ducky method in computer science where you put a duck on your desk and you pretend that they're your coworker, that you're like, hey, I'm kind of stuck on this thing. And then what happens when you're at work or whatever is you'll be like, I've been thinking about this thing, but I can't get it to work. Basically, I'm doing this, doing that. And you're talking 100% of the time. And then you go, oh, I just found it. Right? So basically, the rubber ducky method also applies here, where it's like, if you're solving the homeworks, like, if you're doing it like an interview, it seems like there's a bunch of steps you're doing that's going to make it take way longer. I literally think if you just pretend like you're doing everything like an interview, you're not only reinforcing this good muscle memory so that it's second nature down the road, but also you'll literally finish the homework sooner. You'll have fewer bugs. You'll, all that.
All right. I'll apply it wherever possible.
Yeah. Yeah.
Dad, in one of our classes, they actually like handed us out a bunch of rubber duckies so that we could. It's like a well-known like computer science thing. Is to
All right.
out for someone, yeah.
Here, I'll use my Donkey Kong.
Oh yeah.
Better. I mean, when I was doing when I was doing leak code, I was like, I was just on the bus like whispering. You know what I mean? Like. And yeah, at the time I was visualizing, it's because I'm practicing for interviews and all this, but it also just makes me solve the problems faster. In aggregate, maybe there are some problems that I can just right out the gate and just have it. And yeah, sure, those ones, it's going to be slower if I'm writing pseudocode and doing all this. But I'm not given those problems when I'm interviewing at Google. I'm given the hard problems. And those hard problems, it literally saves time to do it like this. And I don't know how y'all's problem.
Why not prepare for the worst case? Like, what's the problem if every easy thing you encounter you take twice as long at, and then everything that matters you do it in time? It's like, that's a trade-off.
And then it's like, it took you a little longer, but you're not learning. Like, it's not important that you're learning stacks and queues right now. Like, the most important thing you can learn, I think, is basically this, which is how to solve these hard problems. You know what I mean? And so if that problem took you, 10 minutes instead of 5 because you were doing this, okay, but you were practicing the process, and down the road, that extra 5 minutes you spent doing this it'll pay for itself tenfold, because you'll just write fewer bugs when you're doing Assassin Manager or stuff like that, right? Like, I will say the next homework, it's hard to do it with this, because understanding what the fuck the spec is talking about, you'll see. The Guitar Hero assignment, it is just hard to do this with. Oh, yeah. It is kind of the one exception.
I'll keep that in mind. Okay. Well, hey, thank you so much.
Yeah. I'm gonna finish this problem.
Give it a crack.
Cool.
I think I'll give it another crack too, but probably just limit myself. And make sure I use this top-down process.
Yeah. I'm gonna finish it, and then like on my own, and I'll be doing it out loud, and I'm talking into the mic and presenting it. And then if at any point you want, you can just watch me do that, because I'm streaming
great.
It. So cool. You can see how that went for me. I think you'll be pretty like, damn, it really does just go from pseudocode to real code real quick. It's the code kind of writes itself once you've got the pseudocode.
Okay.
So it's awesome. It's like it feels so good to write code once you have like rigorous pseudocode. It's great. Word. Good shit.
Hey, thank you.
Yeah. All right, I will go finish that on my own.
Okay.
Later. Okay. Has this been capturing my audio? Yes, it has. Great. Okay. So, actually, I'm going to bring that over here. Should I just do it in this? Yeah, sure, I will. Fuck it. Okay, so can I X this out, X this out, X this out, X this out? Oh man, I'm gonna have a hard time getting that back. Okay. So, first I'm gonna implement get new interval. So, private void get new interval. This is not null. This is a int bracket bracket because that's what our intervals are. Get new interval. Okay. And so what this is going to take is a list of int bracket bracket intervals and the int bracket bracket to insert. Okay, here we go. Oh man, this sucks. I can't even see the code. Okay. Oh, but why am I getting so many phone calls? Okay, so get new interval, list in a bracket, bam. Okay, so basically what this is going to do is all this. So in bracket bracket, and this could be null. Left interval equals get interval containing of to insert start. Okay. And then in bracket bracket right interval, this could be null, equals get interval containing to insert end. Okay, cool. And then if there is not a left or right interval, so I'll say if left interval is null and right interval is null, then we're saying find where the new should be inserted and put it there. Okay, actually, yeah. So really what I'm going to do here is I'm going to say new interval. And that's going to be null. So we've got this new interval. So actually, I'm going to say new interval is equal to insert, right? Basically, it just goes somewhere in the thing. Awesome. Okay. Else, if left interval is equal to right interval, well, what do we have here? Then, well, we're going to say new interval is equal to, oh, wait. No, I'm saying else if both left and right interval are not empty. So if left interval not equal null and right interval not equal null, what am I going to do? Okay, so actually I'm going to say special case if left interval is equal to right interval, what are we going to do here? I want to set this to null, which is actually basically doing nothing. So I'm actually just going to have a case for if they are not the same, because I want to do nothing if they are the same, then I will say new interval equals new int bracket bracket of left interval of 0 and right interval of 1. There might be some compiler errors there. I don't really remember how to do that. Whatever. Okay. So that's that case. Else if only the left exists, so I'll say left interval does not equal null. So at this point we know that the right is null. So we will say new interval equals, I'm going to copy this. So it's left interval of 0, and then to insert at 1. Feels good. And then I will say else. So that's actually going to be to insert at 1 and write in 0 and write insert at 1. So given not start. Yeah. Okay, cool. So that is that. This is going to give us our thing once we return it. Return new interval. Okay. So then we're saying public in bracket insert interval, and this is going to take the same here. Bam. And I will say in bracket new interval equals get new interval. I'll give it intervals and to insert. And then I have my other method, which is build result with new interval. So I'll say return build result with new interval, and I give it intervals, and I give it the new interval. Cool. So I need to implement this, and then I'm going to implement those, but I'm not even thinking about that right now. And on a real interview, they probably wouldn't even have me do it, because I'm base, and they trust that I can. Private, int, list. Oh, I'm returning a new list. Sorry. List of intervals. List of intervals. Build result with new interval. Okay. So this is going to be same as this, except instead of calling it to insert, I'm actually going to call it new interval. Okay. So what's the pseudocode do here? I'm going to add all fully left intervals. All right, wait here. List of int result equals new array list diamond operator. Okay, so got my result. I want to add all of the fully left intervals. Okay. So cur equals 0. Cur index. Okay, add all the fully left intervals. And then I'm going to do while element at cur, while intervals at cur. Hold up. I need to make sure it's not empty. Okay, so while cur is less than intervals dot length and intervals at cur does not overlap. So what I would check with that is that while, let me think. So all of the left ones. So if there are no left ones, so basically it's fully left. I'm adding all the fully left intervals, and it's fully left if intervals, if the finish, so the finish 1 is less than new interval start 0, right? Fuck, this is annoying. new interval is 0. So I'm adding all the, okay. Right? That makes sense. Yeah, so it's fully left if the, oh my god, this needs to be dot get. Yeah. Okay, so now we have one that's fully left. So I'm going to do cur plus plus. Well, I'm going to do cur plus after, but then here I'm going to say result dot add intervals dot get of I. That makes sense to me. Okay, so at this point I've added all the fully left ones. Okay. Then I need to increment cur until looking at 1 to the right. Until looking at a fully right interval, right? So I'll say while cur is less than intervals dot length, and it's fully right if intervals dot get. Oh, this is I. It needs to be cur. Intervals dot get of cur. Intervals dot get of cur is less than. All right, greater than. No. While intervals dot get of I occur, so while the finish is less than new interval start 0. That's not right. If it's fully, okay, so add all the fully left intervals. Oh, yeah. Increment cur until looking at a fully right interval. So that, I'm not looking for a fully right interval here. I'm looking for one that overlaps at least a little bit. So at that point, it overlaps a little bit if the start of the one I'm looking at is before the finish of this one. That makes sense. So like, I'm just gonna use my mouse here. So like, first we added all the ones to the left. We're inserting this one, and we've got these. Bam, bam. The start here, actually this should be less than or equal to, oh my god. Let me think about if this should be intervals occur. The finish is less than, so it's fully left. I'm gonna change this to say pass all the nodes that are overlapping. So here I'm looking for fully left, which means that this is strictly less than this. Awesome. Then I'm passing the nodes that are overlapping at all, which it's overlapping at all at this point if the start of our guy, so like here, is less than or equal to the end of this guy. Yep, I like it. I like it. So while that's a thing, literally moving on. Now we insert our node, right? While, that's not a while. That's literally just result.add to new interval. And by node, I mean interval. And then add all the fully right intervals. So I'm going to say cur less than intervals dot length, and actually add the rest. Result dot add intervals dot get at cur plus plus. and then I return result. Okay. So now I'm done with the problem, except I need get interval containing. And that should not be too hard. Let me do it. Private in bracket get interval containing. Yeah, I mean, this is actually so easy. I just say for in I equals 0, I is less than. Oh, whoops, I need intervals. Get interval containing needs to also pass in intervals. Intervals, and then int, I'll call it a point. I is less than intervals dot length, I plus plus. What am I going to do here? I'm going to say if, actually wait, this can be a for loop, sorry. For each, in bracket, sorry, it can be a for each loop. In bracket, interval, in intervals, and then I say if interval, interval, if the start is less than point, say less than or equal to point, and, sorry, start is less than or equal to point, and the end is greater than or equal to point, then we return interval. Otherwise, we didn't find one. Okay. I just click submit. Does it work? Probably not. That was a lot of code. Oh! Array list is not much. Oh. Well, you'll unlearn that. Oh, it's array list of integer? Holy shit. Alright, let me make some of these changes. And this is an array list? Okay. Oh, wait. Can I do it like list of integer? Does that work? I think that works. And then this is a list of, okay, so they're integers. They're lists, I mean. Integer. Normal interview wouldn't give a fuck about this. Okay. Bam. 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 Dot get 0. Dot get 1. Oh God, how make it? How to create array list with values in Java. Come in. What up? Not much. I am
Computer science.
doing a computer science thing. Oh my fucking God. It's stupid. But I'm gonna be done in like 15 minutes, and then I will be.
I can ask if Vanessa is home.
Vanessa is home.
It's not like she
Big time.
About a day in the car.
Nice. Okay, hopefully this works for this. New interval equals new array list, arrays.as list. Arrays.as list, and I pass that into. Was she in there?
I think she had just gone to the bathroom.
Think what?
I think she had just gone to the bathroom.
Oh, okay. Oh my god, this is hell. This is hell. Let me see if that works. Left intervals equal no, am I?
I think last week when we went to Topgolf, I left my bacon.
List. Oh, that's
Side.
fucking hell.
My keys are right there.
Array required.
It's the silver card.
Yeah. I think it's just.
Arrays.
Right?
Yeah.
Thanks.
Good luck.
Thank you.
Arrays.as list. What the fuck? Arrays.as list. Left interval? Right interval. Oh wait. Left interval dot get there. Right interval dot get there. This is such hell. This is not demonstrating the thing I was trying to demonstrate, which is that it's really easy to write the code once you have the pseudocode. The problem being,
This problem is not a good
it's
problem to do that with.
it's. I mean, the thing is, it was the code was flowing out just super great, but then it was like, oh, I'm supposed to be using array lists instead of arrays, which like wouldn't happen on an interview, you know. So all this code flowed out in like a few minutes, but now I'm like, oh, I need to rewrite all of it.
Oh, that's so ass.
Yeah, it's a pain in the ass. You have a mismatch between data types. Array lists cannot be converted to a list of lists of integer. Oh my fucking god. Sublime. Come in.
You get it?
Yeah. Or I can put them over there.
Oh, thanks.
I should have just taken my thing and checked if it worked. Okay. Java.
No, you're fine. Have fun, you nerds.
Yeah. What the fuck? Java. Oh, you need to pick. Yeah, Java, not Java properties. Okay. So everywhere where I say list, do array list. But then here, I just want to do array list. As list. Okay. So everywhere I say in bracket, bracket, y'all need to be an array list of integer. This is such gross code now. Okay, so now here I would say new interval equals left interval that get a 0 to insert get a 1. Okay.
I'll go walk.
Cool. To insert dot get of 0, right interval dot get of 1. Okay. 0. Here I'm going to say dot length. Dot length. Dot size. Boom! 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 Holy shit, dude. I mean, literally, aside from that's crazy, actually. This problem, if I subtract the time that it took to convert from fucking integers to array lists, the code just went boom, perfect first try. And I typed it in the web, dude. Oh! Stop streaming. That's how we do it. That's how we do it.
Yeah.
Like, first time clicking submit when it compiles, it works.
That's sick.
That's why